Hey, it's You'll Be Blessed here, making it clear, making it plain, opening up the heavens for my teaching is like spring rain. And today we're going to look at writing chemical formulas for ionic compounds containing transition metals. Let's begin with this example of iron 3 chloride. The first thing we want to do is verify our charges for iron 3 chloride. We can do that with any periodic table of your choice or list of ions. Based on the Roman numeral 3, iron has to have a positive 3 charge. In the meantime, chlorine or chloride prefers to have a negative 1 charge. Let's write it. Here they are. The next thing we need to do is find the least common multiple of 3 and 1. Well, that should be easy. Other than 1, the answer has to be 3. We set the least common multiple equal to positive 3 and negative 3 because we want the total net charge to be equal to 0. Opposite but equal. The next step is to take the least common multiple and divide it by the charge. For iron, a positive 3 divided by a positive 3 is equal to 1. For chlorine, a negative 3 divided by a negative 1 equals 3. Thus, the final answer is FeCl3. Let's look to another example of writing chemical formulas for ionic compounds. Iron 2 phosphide. Notice that it contains a transition metal. Let's begin by verifying the charges on our ions. Because there is a Roman numeral 2 in the name, that means iron must have a positive 2 charge. And then we verify that phosphorus has a negative 3 charge from the periodic table of your choice or some type of ion list. Let's write it. So the next step is to find the least common multiple between 2 and 3. 2 and 3 can't really multiply into each other, but they can multiply into 6 and negative 6. Notice that we are setting up equal but opposite lowest common multiples. The reason why we're looking for the least common multiple is so that iron and phosphorus can combine to make an overall neutral charge. The next step is to take the lowest common multiple and divide it by the charge of that ion. For iron, positive 6 divided by positive 2 is equal to a positive 3. For phosphide, a negative 6 divided by a negative 3 is equal to a positive 2. And so the final answer is Fe3P2. Let's look to another example of writing chemical formulas for ionic compounds. This time we're working with vanadium 5 oxide. Knowing that this contains a transition metal, we need to verify the charges of our ions using a periodic table or a list of your choice. Here we notice that it is possible for vanadium to have a positive 5 charge. That's what the Roman numeral tells us. And then oxygen is verified to have a negative 2 charge. So the next step in our process is to find the least common multiple of 5 and 2. We want the number of vanadium and oxide ions to be equal but opposite in their total charges. So the least common multiple here is going to be 10. 2 and 5 can't go into each other, but they can go into 10. The next step in this process is to take the lowest common multiple and divide it by the charge of its ion. For vanadium, a positive 10 divided by a positive 5 is equal to a positive 2. For oxygen, negative 10 divided by negative 2 is equal to a positive 5. And that final answer is V2O5. Thanks for tuning in to You'll Be Blessed STEM Education. I hope you were blessed by the contents of this video. And if you were, be sure to like, comment, and subscribe to this channel for more teachings that feel like a refreshing spring rain.